Good morning, students. Welcome into the another session of CS22 Operating System Concepts using Linux and Unix. As we are discussing about the unit number 3 called Memory Management. In this particular unit, we have discussed many things like what is memory management, different types of memory, memory allocation address, discussion about dynamic memory allocation, two types of allocation called contiguous memory allocation and non-contiguous memory allocation. And at last, we have stopped our previous discussion by comparing contiguous and non-contiguous memory allocation, which you can see onto the screen. After that, the next topic to be discussed is virtual memory using pagination. So over here, we have to introduce the new word called pagination. What does it means? How it works with virtual memory, all these things we are going to discuss in virtual memory using pagination. So the first thing that we have to clear is what is pagination. Here the pagination means, or you can say paging means, it's a one type of process where the number of information is divided into the equal number of pages. That is called as pagination. Say for example, I am just taking a general example. Suppose over here I am typing google.com and here I am giving the name of our college. Just scroll it down. Here you can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. This thing is known as paging. In general terms, in web development terms, this is called as paging, where the entire information related to this particular search criteria is divided into the number of pages. Whenever you click on second page, you will get the second page of this entire search, third page, fourth page and so on. That is called as pagination. Even we can say that it is just like an index that we are maintaining for our journals. The index page of our journal is also called as pagination, where what we are generally writing, the date, the topic number, topic name, page number and the date. That means we can directly go to that particular page for relevant information. Say for example, suppose we are maintaining the journal of programming in C, where on page number 10 there is a program to display 1 to 5 number using for loop, and on index you have mentioned that topic number, that is display series using for loop, then you have written page number 10. So anyone can recognize that the looping control structure for displaying the series of 1 to 10 number is on page number 10. We can directly go into the page number 10 for browsing that particular program. No need to search for displaying the series of 1 to 10 number on each and every page of a journal. So that is the purpose of index. Just think for a moment that suppose we have not mentioned the journal and we have written lots many program in our journal without any index and without any page number, and after some years you want some information similar like this, that means you want to display the series of number from 1 to 10, then what we have to do, we have to search for that particular program in each and every pages. So it's a wastage of time and even it requires lots of efforts. So to reduce that particular efforts and increase the slower rate time, to decrease the slower rate time, this particular concept has been introduced over here called virtual memory using pagination. So let's see how the pagination works in virtual memory. A computer can handle a computer can address more memory than the amount physically installed onto the system. This extra memory is actually called virtual memory and it is a section of hard that's set up to emulate the computer's RAM. Paging technique plays an important role in implementing a virtual memory. Let me repeat my words again. A computer can address more memory than the amount physically installed onto the system. This extra memory is actually called virtual memory and it is a section of hard that's set up to emulate the computer's RAM. Paging technique plays an important role in implementing the virtual memory. Paging is a memory management technique in which process space is broken into the number of blocks called same size called pages, where size is a power of 2 between the 152 bytes and 8192 bytes. The size of process is measured in number of pages. That means, as I told you earlier, that the entire number of processes are equally divided into the number of blocks. That blocks are now called as pages. That means every process which is stored on a specific page contains the address which is called as memory address, and that memory address is maintained by memory management block, and memory management block supports the procedure of central processing unit. The discussion of paging is not limited up to this particular situation. We can extend this discussion by exploring more relevant topics related to the pagination. Each paginations are fit into the specific number of frame or frames. So here there is a new concept called frame is going to come in front of all of us. So let's see what is frame. Now frame means main memory is divided into the small size block of physical memory that is called as frame. That frame is kept the same number of pages up to the optimum utilization of memory and to avoid the external fragmentation. This external fragmentation sorry for the disturbance. Here the staff members didn't know that I am taking the lecture. Let them complete their first discussion, then I will continue my lecture. Fine. Let's continue our discussion. Sorry for the interruption. Let me again revise the topic that we are discussing. We are discussing about one of the most important concept now in operating system, that is called as pagination. Here the pagination, or we can say the paging, means it is a procedure of dividing the number of process into the equal number of blocks where each and every block contains unique memory address for unique procedures. That procedure is maintained by the memory management block and directly related to the central processing unit. The size of paging is decided by the procedure which is called as pagination, where it considers the size of power 2 between the 512, that is 512 bytes, to 8192 bytes. Pagination no doubt provides the facility to access the particular process directly without looking into the each and every blocks. But this discussion is not limited up to that particular extent, even it contains lots many internal technical aspects also. That technical aspect, first technical aspect is frame. So let's see what is frame. Frame means, first of all, it is related with the main memory, that is also called as a primary memory, we can say the random access memory, whatever. So we can say that main memory is divided into the small number of fixed size of block, which is called as physical blocks. That particular block is called as single frame. And the size of frame is kept same as that of page, have optimum utilization of main memory to avoid external fragmentation. This is the purpose of using frame. The purpose of frame is to fragmentate the memory. Now here first we have to clear a one more technical word called fragmentation. Fragmentation is actually a one type of process which is handled by memory management block. Now what it does into the fragmentation, whenever the fragmentation is initiated by the memory management block, it rearrange all the occupied memory block from the main memory, and it rearrange the entire block in such a way that all occupied block came at the bottom side and all the free blocks, which is also we called as a memory holes, came upper side. Let me show you one process into the operating system which demonstrate the use of fragmentation. Here I am just typing that defragmentation and let me run this particular process. Here it will ask for the drive. Let me select the drive called C, and suppose I am clicking analyze. Now as you can see that this process is running and it shows a fragmentation into the number of percentage. So what this particular process do inside? No doubt this is for hard disk and we are discussing about the memory management block, but this procedure is similar look like. This particular process search for the occupied number of space first. It collects all the process, all the information about the occupied space, and it reallocates all that particular space on a one side, and on another side it keep all the free space. So whenever any new request comes for storing the data without disturbing and without going into the search of free space, it will directly occupy the free space from the particular block. So this is called as a fragmentation. Whatever I have shown you, it's a fragmentation for internal storage for the secondary storage device, and right now we are discussing about primary storage device. Same procedure is handled for primary storage device 2. That thing is demonstrated over here in terms of a one table, where you can see that there is a number of processes are there on left hand side. Every process is given a unique address called every process is stored on site inside the number of pages called page 0, page 1, page 2, 3, 4, 5, 6, 7 up to n. All that pages contains sub processes. Say for example, on page number 0, it refers only the single process called F2. On page number 1, it contains 4 different processes. On page 2, it contains 3 different processes. On page 4, it contains 2 different processes, and so on. So this is a simple example of pagination. That means one thing is very clear, that in between the process and main memory, our new concept get fitted, that is called as pagination, which actually helps the secondary memory to maintain their particular data. Let's move on. Now this entire process, that means assigning the process into the particular page and then fetching the process from a particular page to the main memory and so on, vice versa, they technically get handled with many topics like address translation, that means it uses address translation. So let's see what is address translation. Address translation means first it is related with the page address, which is called as logical address, and it is represented by a page number and its offset, where address translation contains the physical address as well as the logical address, where logical address is counted by applying one equation, where equation says that logical address is equals to page number plus page offset. So here I would like to justify the page number and the page offset. This 0, 1, 2, 3, 4, 5, 6, 7 are the page number, and this F0, F1, F2, F3, F4 and F5 are the different types of offset. So logical address is counted based on number of pages and number of page offset. Similarly, into the address translation, not only the logical address works, but also the physical address works. So physical address is assigned by considering one more equation, that is called as physical address is equals to frame number plus page offset. So let me show you that where is the frame number and where is the page offset. So this is the frame number, this F0, F1, F2, F3, F4 and F5, where the prefix is given as a F. So these are the frame number, and these are the offset, which stores inside the specific frame. It represents the physical address. Before going ahead, let me repeat fastly that whatever we have discussed. What we have discussed? We have discussed two most important things. One is the pagination. In short, it's a process which demonstrates number of processes which is generated by the central processing unit is going to be stored on equal number of block which can be located on a specific address of the main memory, which is known by memory management block and initiated by the central processing unit. Then after the discussion of pagination, we go for demonstrating a one block where the pagination process is initiated by the main memory. The pagination process which is initiated by the main memory is done using the address translation, where address translation considers the two different things that is called as the occupancy of physical address and the logical address. Logical address is counted by the memory management block by applying a one equation which is called as page number plus page offset, and physical address is applied by a one equation which is called as frame number plus page offset. This is actually a one map for the central processing unit which directed by the memory management unit, which helps the central processing unit for easily storing and retrieving the process into the memory management block. One thing is very clear: without allocation of the temporary storage space, none of the process get executed into the system. That is the first line that we have discussed at the time of this chapter's discussion. So central processing unit requires a very micro process, a very micro information of the process where actually it is stored. So that could be done using this pagination process. This pagination process have its own advantages and disadvantages, which can be asked into the examination. Pagination actually reduce the external fragmentation, but it still suffers from internal fragmentation. It is something sounds like internal sorting and external sorting, which we have discussed into the data structure. Let's move on first. Second advantage is that paging is simple to implement and assume as an efficient memory management technique. Due to the equal size of page and frame, swapping becomes very easy. That means swapping from frame to the block and block to the frame. It is a procedure of exchanging the information between the two blocks. Page table requires extra memory space, so a very small amount of random access memory can get occupied by the pagination. This was all about the technique called pagination. In our next lecture, we'll go for the another concept that is called as segmentation. Before concluding the lecture, the topic that we have discussed in this particular lecture are: what is pagination, how pagination is handled by the memory management block. During the pagination, it considers the two types of address called physical and logical address space. And then finally, we have discussed about the various advantages and disadvantages of pagination. And in our next lecture, we'll go for segmentation. Thank you very much, students, for listening me, and have a nice day.